In this video, we will cover about displacement time graph. So when you have a displacement time graph, the y-axis is about displacement. I put it as x, and your x-axis will be your time, which is here in second, and my y component meter is in meter, and my displacement is in meter. So let's put it this point A, this point B, and here point C, and we have point D, E, and also F. Okay, this graph, you can have your reading. Apa yang menggambarkan graph ini adalah, for example, let's say we have like we have a straight line. You are moving in a straight line. Okay, we will have a reference point. Let's say your x is equal to 0 here. Point A is, if you can see, you are starting at point A because your time is 0. Okay, your time is 0 here, 0. That means your position is here, which is when we read it, it is 50 meter positive. Kalau tengok kat sini, dia punya point is 0 and 50. Positive 50 meter show that your position of A is to the right of your reference point. Ke kanan lah sebab dia positif. So let's say your point A is here, which is 50 meter ke kanan. This is point A. And then dia bergerak ke point B. So point B ni kalau awak baca dia punya koordinat, dia 10 second dan kedudukan dia lebih kurang dalam 160. Okay, kedudukan dia lebih kurang 160, which is you punya B ni berada di 160. Okay, saya letak kat sini. 160 meter. This is your B. Time taken is equal to 10 second. This is your starting point at A. And then you are moving to point C, which is point C, you are at 20 second and 200 meter from your positive x-axis, from your reference point. So let's say this is your C, 200 meter, and time taken here is 20 second. Okay, from A to B, you are moving to the right. Okay, from A to B, you are moving to the right. Same as from B to C, you are moving to the right. But now, your D is at, let's say here is your point is 30 second, and the position, let's say it is at 165 meter, which is, it is somewhere here. Okay, saya sambungkan ke atas. This is your D. It is at 765 meter. Time taken here is time taken is 30 second. So from C to D, you are moving to the left. Okay, you are moving to the left. Okay, this is, let's put it as XAB. Okay, B to C, let's put it as XBC. And your C to D, let's put it as SCD. Showing that it is displacement from C to D. And remember that your displacement is a vector. Now, okay, now let's put that the point E. Your point E is at 74 meter, 40 second, and 74 meter from the origin. It is somewhere here lah. This is your point E. It is 74 meter from the origin, and time taken is 40 second. This is point E. So from D to E is also to the left. XED. Okay, now let's look at from E to F. Your point F is at it is below 0, below origin. It is below origin. Should be, it is at 50 second, and it is negative 75. Kalau tengok dekat coordinate point, dia adalah negative 75. This negative showing that it is at to the left of the reference point. to the left of x equal to 0 ni lah. So dia somewhere here. This is your F, which is negative 75 meter. Time taken is 50 seconds. So from E to F is also to the left. X, E, F. Alright. Now, kalau kita nak, kalau soalan minta, what is the displacement at t equal to 35 second. This one, you just read it from the what we call from the graph, which is 35 second is here. You just extend it up until you find the graph, and then go to the y axis. You will get something like 100. Your displacement at 35 second is equal to 120 meter. This is 120 meter. But now, let's see. You want to find the average velocity and instantaneous velocity. So let's look at, first we will look at average velocity, and then we will look at instantaneous velocity. Let me erase this first. Okay. You will have two types of velocity. The first one is average velocity. To get average velocity in this graph, you need to connect a line between initial point and final point. Then find the gradient. That means your average velocity is equal to the gradient of the line connecting two points, connecting initial and final position. Initial and final position. Let's say we want to find the average velocity between B and E. Okay, between B and E. Alright, B and E. So let's find a line that connecting between B and E. We need to find the gradient of this line to sampai sini je. Okay, to get the velocity of point B to E. So if your velocity, if your gradient is positive, showing that your average velocity is also positive. To the right lah. Ataupun kalau kita consider dia motion upward, in y axis it is upward. Kalau your gradient is negative, you will get your average velocity is also negative. So B to E, dia menurun kan, dia punya graph menurun, maksudnya you will get negative lah later. So we want to find the average velocity. We will use y2 minus y1 bahagi dengan x2 minus x1. We will get something like here 74 minus 160 divide by 40 minus 10. I will get it as negative 2.87 meter per second. So let's look at the negative sign. Negative sign showing that your velocity is to the left. Okay, we will look at, now we are considering from B to E. From B to E. So from this point to this point. So now this is your initials and this is your final. Okay, daripada B nak pergi ke C, dia ke kiri. Ya, B nak pergi ke E, dia ke kiri. Ini kita nak cari dia punya average. So average kita ambil yang final lah, yang displacement bahagi dengan time. So displacement antara B dengan E adalah this part sahaja. So dia ke kiri. That's why you got it as negative. Alright, now we are going to look at instantaneous velocity. We are going to look at instantaneous velocity. Okay, let's you can fast forward this. I just want to erase this. Okay, fast forward this. I just want to erase this. Alright. Now we want to find instantaneous velocity. So instantaneous velocity is, you can get instantaneous velocity by finding the gradient of the tangent at that point. So let's say gradient of the tangent at that point. We want to find the gradient instantaneous. Remember, the instantaneous velocity is the velocity at that point or at that time. So let's say I want the instantaneous velocity at time equal to 10 second, which is, or it is at point B. Okay, apa yang awak perlu buat adalah awak kena cari gradient yang menggambar, yang what we call, dia akan ambil apa ni, satu garis, which is, we will get it something like this. Gradient sini, let's say okay, let's look ini. Okay, macam tu. You kena cari satu garis di mana sudut atas ni dengan sudut bawah ni adalah sama. Agak-agak je. So yang ini point dekat atas ni, saya dapat point dekat sini, which is by trial and error, I got this as 18 and 220, and the below one I got negative 460. But trial and error. Jangan tanya saya macam mana macam mana madam tentukan point ni. Tak, saya buat by trial and error. So saya dapat ni kat sini. This is the triangle that I need to find the gradient. So V at B, I should get as Y2 minus Y1 divide by X2 minus X1. Ni dia punya equation lah. So I will get it as positive, you will get it positive 7.3 meter per second. Okay, tengok graph dia ke kanan, so you will get it as positive. So let's for example, I want V at D, at point D. Okay, I want the gradient at point D. So what I need to do is find a gradient here. Ni kena buat lah, cuba jaya lah. Okay, find a gradient here that have the same angle below and above. And when you find this, I will find my gradient as equal to negative 12.2 meter per second. Showing that at point B, okay, at point B, you can see at point here, you are moving to the right. This is point B. At point D, you can see at point D here, you are moving to the left. B bergerak ke kanan, D ni dekat point D ni dia bergerak ke kiri. Right? Okay, so I will erase this. Okay, the gradient at, let's for example, mana dah? Okay, at point C. Okay, at point C, we will have our gradient is equal to 0. Kalau kita cari tangent dekat point C ni, you akan dapat straight line. Ni kan point C tadi kan. So V dekat C, gradient dia sama dengan 0, which is V equal to C pun akan jadi 0. This is instantaneous velocity. Instantaneous velocity adalah 0 meter per second. It's showing your turning point. Turning point, where the point you change the direction. Change the direction. Okay, kalau tengok pergerakan ni pun, daripada A pergi ke B, pergi ke C, dekat point C ni awak patah balik. So C ni adalah point, turning point. So your gradient is equal to 0. Okay, now, okay, your graph can be represented as an equation. you can have equation of quadratics. Okay, you boleh ada equation ni dalam bentuk quadratics, which is you will get it as your equation should be like this. Your x equal to at square plus bt plus c. Okay, your t is your x in x-axis and your x is your y-axis. Okay, a, b and c is a constant. Right? And you also can have the equation in cubic, which is, this is my equation lah. X equal to at to power of 3 plus bt to square plus ct plus t. I have plot this graph by using an equation where my equation is x equal to 0.001 t square t cube minus 0.4 t square plus 15t plus 50. So if I said I want an instantaneous velocity, my definition for instantaneous velocity is v equal to limit t approaching to 0 delta r over delta t, which is, this is the definition for differentiation of dr over dt. So I will get our v by differentiate, it is using x kan, so saya akan guna x jugalah. By differentiate this equation across t, I will get it as 0.003 t square minus 0.8 t plus 15. So this is my v lah from the equation above. If I want the velocity at t at b tadi kan, dekat b ni kan tadi, sini b, b ni t equal to 10 second at b. I just substitute into the equation. 0.03, my t is 10 second, square minus 0.8, 10 second plus 15. I will get approximately 7.3 meter per second, which is the same as the gradient from the tangent that I calculate before. Here this tangent kan, kita ada tangent tadi, which is, this is dia punya tangent. Tadi kita dah kira kan. So tangent ni dekat point B sama dengan kalau saya kira guna equation, if you have any equation. Okay.